Okay. Let a1 and a2 be the constant and consider L of y, okay, which is equal to y double dash plus a1y dash plus a2y, okay, which is equal to 0. And if alpha plus minus I beta, okay, this is the complex number, are complex conjugate roots of roots of characteristic polynomial p of r, okay, which is equal to r square plus a1r plus a2 is equal to 0. Okay, then the function then the function defined by phi1 of x, which is equal to e raised to alpha x into cos beta x, okay, and phi2 of x is equal to e raised to alpha x into sin beta x. Okay, these phi1 and phi2 are the solution of are the solutions of L of y is equal to 0. Okay, this is the phi1, which is equal to e raised to alpha x into cos beta x, and phi2 is nothing but e raised to alpha x into sin beta x. Okay, now let's see the proof. Okay, proof. Let a1 and a2 be the constant. Okay, let a1 and a2 be the constant, and L of y is equal to y double dash plus a1 y dash plus a2 y, which is equal to 0. Give it as equation number 1. Be the second order homogeneous linear differential equation. Okay, here alpha plus or minus I beta, okay, are the complex conjugate root, are the complex conjugate conjugate roots of characteristic polynomial p of r. Okay, here alpha plus or minus I beta are the complex conjugate roots of the characteristic polynomial p of r. Then by previous theorem, we know that by previous theorem, what we have, e raised to, okay, alpha plus I beta into x and e raised to alpha minus I beta of x, okay, are the solutions of L of y. Any doubt up to here?
No, sir.
E raised to r1x and e raised to r2x are the solution of L of y. Now putting r is equal to alpha plus I beta and alpha minus I beta. Okay. Again, we know that again one more theorem, the linear combination of solutions is again a solution. Okay, again by previous theorem, we know that the linear combinations of e raised to alpha plus I beta x and e raised to alpha minus I beta of x. Okay, is the solution of L of y is equal to 0. Okay, any doubt?
No, sir.
Okay, now consider the linear combination of these two, phi 1 and phi 2. Okay, consider the linear combination of these two solutions. What is the linear combination? C1 into e raised to alpha plus I beta of x plus C2 of e raised to alpha minus I beta x. Okay, which is equal to C1, okay, e raised to alpha x into e raised to I beta x. Any doubt up to here?
No, sir.
स्प्लिट केलं त्याला फक्त आपण C2 into e raised to alpha x into e raised to minus I beta x. Okay, so here we get which is equal to e raised to alpha x is the common, and in the bracket C1, okay, e raised to I beta x plus C2 into e raised to minus I beta x. But what is the value of e raised to I theta?
Cos theta plus I sin theta.
Very good. Cos theta plus I sin theta. So putting here e raised to alpha x into C1. What is the value of e raised to I beta x? Cos beta x plus C1 I sin beta x. Okay, any doubt? So this
No,
is the
sir.
first. Okay. Now plus again C2 e raised to minus I beta x. What is the formula? Cos beta x minus I C2 sin beta x. Okay, understood up to here?
Yes, sir.
So this is the bracket, whole bracket,
Yes, sir.
which is equal to e raised to alpha x in the bracket. नीट लक्ष देता C1 plus C2 into cos beta x. Okay, plus I into C1 minus C2 sin beta x. सॉल्व केले पण काहीच नाही केलं त्याला. ओके, एनी डाऊट?
No, sir.
तुम्हाला काही डाऊट आहेत का समोर?
No.
Which is equal to, okay, now put C1 plus C2. These are the both are constant. Now putting this value C1 plus C2 assuming A, and this C1 minus C2 assuming this value as a B. So what we get? E raised to alpha x into A cos beta x plus I, okay, sorry, where A is equal to putting C1 plus C2 is equal to A, and B is equal to I into C1 minus C2. So here we get beta, sorry, B into sine beta x. Okay, any doubt?
No, sir.
Okay, hence which implies that C1, okay, e raised to alpha plus I beta of x plus C2 e raised to alpha minus I beta of x, which is equal to e raised to alpha x into a into cos beta x plus b into sine beta x. Okay, this one is b and this one is beta. Okay, but we know that the linear combination of these two is the solution. Hence, this is the solution. It means that e raised to alpha x into a cos beta x plus b sin beta x is again the solution. Okay, this shows that the solution L of y is equal to 0 is linear combination of linear combination of e raised to alpha x into cos beta x and e raised to alpha x into sine beta x. Okay, therefore we have we get the function phi 1 of x is nothing but e raised to alpha x into cos x, sorry, cos beta x, and phi 2 of x is equal to e raised to alpha x into sine beta x are the solutions of given differential equation L of y is equal to 0. Okay, आपण बीएससी पार्ट 1 ला बघितलं, जर कॉम्प्लेक्स कॉन्जुगेट रूट्स असतील तर आपण हे कसं लिहितो, त्याचं कॉम्प्लिमेंटरी फंक्शन ई रेस टू अल्फा एक्स इंटू ए कॉस बीटा एक्स प्लस बी साइन बीटा एक्स. ओके, तेच इथं प्रूव्ह केलेलं आहे. ओके, एनी डाउट अप टू हियर? This is
No,
the phi 1
no,
and
sir.
this is the phi 2. Okay, now solve this example. Example number 1. Y double dash plus 16y is equal to 0. Tell me the phi 1 and phi 2 and also phi, their linear combination. What its characteristic polynomial?
R square plus 16 is equal to 0.
Very good. Not find out R and tell me phi 1
Plus
of x and x.
plus and minus 4i.
Very good. Plus and minus 4i. Then what is the value of alpha here?
0.
And what is the value of beta?
4.
4.
Now put the alpha and beta in phi 1 and phi 2. Phi 1 of x is equal to cos 4x and phi 2 of x is equal to sin 4x.
Sin
Sin
4x.
4x.
Phi of x is equal to c1 cos 4x plus c2 sin 4x. Look at here. Proof. Given y double dash plus 16y is equal to 0. Give it as equation number 1. Then characteristic polynomial of 1 is r square plus 16 is equal to 0, which implies that r square is equal to minus 16, which implies that r square is equal to, sorry, r is equal to under root minus 16. Okay, which implies r is equal to
Plus
I
minus 4i.
into minus under root minus 16, which implies plus or minus 4.
4i.
Okay, any doubt?
No, sir.
Hence, जर समजत नसेल तर इथेच लिहून ठेवायचे लगेच अल्फा प्लस विच इज इक्वल टू आय बीटा, which implies that alpha is equal to 0 and beta is equal to 4, which implies that phi 1 of x is equal to what? E raised to alpha x into cos beta x, which is equal to e raised to alpha means e raised to 0x into cos 4x. Okay, and phi 2 of x is nothing but e raised to alpha x into sine beta x, which is equal to e raised to 0x into sine 4x, which is equal to, this is one is cos 4x and this one is sine 4x. Okay, and their linear combination is nothing but phi of x is equal to C1 phi1 of x plus C2 phi2 of x, which is equal to C1 cos 4x plus C2 sin 4x. Okay, any doubt?
No, sir.
Okay. Now solve this one. Y double dash plus 2iy dash plus y is equal to 0. Okay, ह्याचे रूट्स कसे काढणार? r is equal to minus b plus or minus under root b square minus 4ac upon 2a. ह्याच्यानुसार काढा. Okay. Now tell me directly r. या फाल काय येणार इथे? r square plus 2ir plus what? Plus 1, which is equal to 0. Now here a is equal to 1, b is equal to 2i, and c is equal to 1. So r is equal to minus b plus minus under root b square minus 4ac upon 2a. Now tell me directly r. What is the value of r? सोडवते ना बाकीचे? आवाज ऐकू येतोय का माझा? Look at here. R is equal to I
I
into bracket minus 1
minus 1
plus
plus or
minus.
I
minus
into 1 plus minus root 2 upon 2.
Okay. Is this
2 to
correct?
x cancel. Yes, sir.
Okay. And what is the phi 1 of x? Alpha काय येणार इकडे? 0. And beta? Minus 1 plus minus square root of 2. Okay. So phi 1 of x is equal to what you get? Phi 1 of x is equal to directly असेल असं लिहिलं तरी चालेल. Okay, look at it. I e raised to I minus 1 plus minus square root of 2. Okay, if you take here plus root 2. Okay, this is the phi 1 and this is the phi 2. E raised to I minus 1 minus square root of 2. Okay, any doubt? असंही चालेल किंवा असंही चालेल. Phi 1 of x is equal to है ना?
cos of minus 1 plus root 2.
Cos of minus 1
Minus 1 plus root 2.
plus root 2 plus I beta e raised to I theta फॉर्म यूज करा ना इकडे. कळतंय का काय चाललंय? I into साइन ऑफ. ओके, नाही तर डायरेक्टली यूज करा, हे फॉर्म्युला यूज करा. आपल्याकडे काय लिनियर कॉम्बिनेशन लिहायचं आहे ना आपल्याला. वी नो दॅट द फाय इज इक्वल टू व्हॉट? फाय इज इक्वल टू काय ना? फाय ऑफ एक्स इज इक्वल टू काय ना?
Phi 1 of
C1 phi 1 of x plus C2
C2
phi
phi
2 of x. Okay, so what we get here at the end? काय ना तो a into cos beta x. What is the beta here? Minus 1 plus minus root 2. Okay, plus beta b into sine minus 1 plus minus root 2. Okay, any doubt? This is the our our solution phi of x. Okay, तुम्ही
Yes,
हे
sir.
सॉल्व्ह करा किंवा हे सॉल्व्ह करा, दोन्हीचा आन्सर एकच येणार. ठीक आहे, C1 इज टू ई रेस टू काय येणार तिथे, ई रेस टू आय आर एक्स लिहितो ना आपण, इथे काय येणार मग, आर किती आलं इथं, हे आय इंटू -1 प्लस एक्स येणार, सॉरी, ओके, हे एक्स येणार, so 2 into x plus c2 into e raised to I -1 minus root 2 bracket of x. हे सॉल्व्ह केल्यानंतर वरचंच येणार. ओके, एनी डाऊट, काय डाऊट आहेत का? ओके, नाव
No,
नाही,
sir.
नेक्स्ट. हां, बोला.
No, sir.
ओके,
No doubts.
एक्झाम्पल हे कधी सॉल्व्ह करा तुमचे. ओके, होमवर्क नंतर सॉल्व्ह करा. y डबल डॅश प्लस 3i minus 1 y dash into y dash minus 3iy which is equal to 0. Okay. Okay, r is equal to किती येणार, 1 and minus 3i. Okay, हे सॉल्व करा घरी. Now the next initial value problem, the next concept, initial value problem for second order equation, for second order equation. Okay, an initial equation, an initial value problem, and initial value problem of L of y is equal to y double dash plus a1 y dash plus a2 y, which is equal to 0, is a problem of finding the solution of the solution phi, which satisfies sorry, which satisfies phi of x naught is equal to alpha naught and phi dash of x naught is equal to beta naught. Okay, where x naught is a real number, and alpha naught and beta naught are two given constant. Okay, what is the initial value problem? पहा इथे नीट. आता तुमच्याकडे L of y is equal to second order homogeneous linear differential equation तुम्हाला दिलेलं आहे. Okay, why this problem is called as initial value problem? Because तुम्हाला इनिशियल व्हॅल्यू तुम्हाला दिलेली असणार. हा x नॉट जो असणार तो तुमचा इनिशियल पॉईंट असणार, दिलेल्या इंटरवलचा इनिशियल पॉईंट. ओके, या आपण सेकंड ऑर्डर लिनियर डिफरन्शियल इक्वेशन वरून आपण काय सोल्युशन फाइंड करतो, फाय फाइंड करतो. ओके, मग हा एक्स नॉट त्या फाय मध्ये ठेवून, बाय पुटिंग दिस एक्स नॉट ॲट द सोल्युशन फाय वी गेट अल्फा नॉट अँड बीटा नॉट. एक्झाम्पल घेतल्यावर लक्षात येईल तुम्हाला. लुक ॲट हियर. नाउ फर्स्ट एक्झाम्पल घेतले की लक्षात येईल. कन्सिडर द इक्वेशन using these two equations, phi of x naught and phi dash of x naught. Okay, find the values of two constants c1 and c2 and putting that c1 and c2 in the original equation phi. Okay, consider consider the equation consider the equation y double dash plus y dash minus 6y is equal to 0. First one, compute the solution. Compute the solution. The solution phi satisfies satisfies phi of 0 is equal to 1 and phi dash of 0 is equal to 0. Second one, compute the solution psi such that phi of 0 is equal to 0, psi dash of 0 is equal to 1. Okay, now again, third one. Now phi of 1, find phi of 1 and also psi of 1. Okay, now look at the proof solution. Now, what we have here, L of y is equal to y double dash plus a1 y dash plus a2 y, which is equal to 0. Give it as equation number 1, which is equal to y double dash plus y dash काय दिलेलं आपल्याला minus 6y, which is equal to 0. Give it this equation as number 1. Okay, this is our L of y. Okay, now what is the characteristic polynomial? Characteristic polynomial of 1 is P of r, which is equal to r square plus r minus 6, which is equal to 0. Now tell me what is the value of phi 1 and phi 2. By calculating the value of r1 and r2, then tell me what is the values of phi 1 and phi 2. Roots काढा, roots वरून त्याची phi 1 आणि phi 2 व्हॅल्यू काढा.
e raised to minus 3x आणि e raised to 2x.
e raised to 2
Oh,
days.
so समजते? Okay, so what are the values of r? 2 and minus 3, which implies that phi 1 of x is equal to e raised to minus 3x and phi 2 of x is equal to e raised to 2x. Okay, then the general solution of 1 we can write, then the general solution of 1 is given by the linear combination of phi 1 and phi 2. Okay, which is equal to phi of x is equal to c1 phi 1 of x plus c2 phi 2 of x, which is equal to c1 into e raised to minus 3x plus c2 into e raised to 2x. Okay, this is the phi of x hour. This is the general solution of 1. Now first one, what we have to find? Look at here. Compute the solution phi which satisfies phi of 0 is equal to 1 and phi dash of 0 is equal to 0. Okay, now here phi of x is equal कदाचित नेट प्रॉब्लेम झाला असेल, आला असेल आता फोन आला होता ना म्हणून तसं झालं. minus 3 into c1 e raised to minus 3x plus 2 into c2 e raised to 2x. Any doubt up to here?
No, sir.
Up to here. Okay, we have मोबाईलचं नेट नव्हतं ना, त्यामुळे तो तसा होतो. मग पुन्हा लगेच we have phi of 0 is equal to 1 and phi dash of 0 is equal to 0. So put here phi of 0, calculate phi of 0. What we have then? C1 e raised to 0 plus C2 e raised to 0, which implies C1 plus C2. Okay, which is equal to काय दिलं phi of 0? 1.
0.
So here C1 plus C2 is equal to, wait a minute, which is equal to 1. Okay, give it as equation number 3. 2 मध्ये दिलं वाटतं होते. Also I have equation number 2 there. Okay, C1 plus C2 is equal to 1. And again, phi dash of 0, which is equal to minus 3 into C1 e raised to 0 plus 2 into C2 raised to e raised to 0. So what we get? Minus 3C1 plus 2C2, which is equal to also, what is the value of phi dash of 0?
0.
Is 0. Which implies 0. Leave it as equation number 4. Okay. Now by solving these two equations, हे इक्वेशन सॉल्व करा आणि C1 आणि C2 ची व्हॅल्यू काढा. काढता येतील? ओके, सॉल्व करा.
Yes, sir.
Okay, what are the values of C1 and C2?
2 by 5 and 3 by 5.
Okay, which implies that C1 is equal to what? 2 by
2
5.
by 5.
And C2 is equal to 3
3
by
by
5.
5.
Okay, now putting these values in equation number above, phi of x. Okay, this one. Which implies that phi of x is equal to 2 upon 5 into e raised to minus 3x plus 3 by 5 into e raised to 2x. So this is the our general solution satisfying these two equation. Okay, what this is the solution phi which satisfies phi of 0 is equal to 1 and phi dash of 0 is equal to 0. Okay, any doubt?
No, sir.
फक्त calculative part आहे यात. Okay, now in second part, let phi of x is equal to c1. हा phi of x आहे ना, आता याला psi of x अजून करा. c1 e raised to minus 3x. c1 e raised to minus 3x plus c2 e raised to 2x. Okay, आणि दोन कंडिशन कोणते दिले आहेत? psi of 0 is equal to what we have 0 and psi dash of 0 is equal to 1. Okay, again by similar method solve this equation आणि सांगा मला c1 आणि c2 च्या व्हॅल्यू काय येतात. So phi dash of x is equal to what? Minus 3c1 e raised to minus 3x plus 2 into c2 e raised to 2x. Okay, now put 0 in both these equations. We get two equations in c1 and c2. Now calculate c1 and c2. Now tell me directly phi of x, psi of x.
C1 minus 1 by 5 and C2 1 by 5.
ओके, आलंय का? So C1 is 1 by 5
Minus 1 by
minus
5.
1 by 5. Okay. Which
And
implies
C2 is plus 1 by
C1
5.
is equal to minus 1 by 5 and C2 is equal to 1 by 5. Which implies that psi of x is equal to minus 1 upon 5 e raised to minus 3x plus 1 by 5 e raised to 2x. So this is the general solution satisfying psi of 0 is equal to 0 and psi dash of 0 is equal to 1. Okay, any doubt?
No, sir.
Now the third one is find phi of 1 and psi of 1. Okay, third part. We have psi of x is equal to c1 e raised to minus 3x plus c2 e raised to 2x, which implies that psi of 1 is equal to c1 e raised to minus 3 plus c2 e raised to 2. Okay, and also psi of 1 is equal to c1 e raised to minus 3 also and c2 e square. Okay, any doubt?
No, sir.
Okay, now the next example is homework. Okay, homework. Second one. The solution of find the solution of y double dash plus y is equal to 0. First one, which satisfies this condition. Okay, phi of 0 is equal to phi of 0 is equal to 1 and phi of pi by 2 is equal to 2. Second one, ह्या दोन कंडिशनच्या यूज करून काय करायचं आपल्याला C1 आणि C2 ची व्हॅल्यू काढायची, बाकी काहीच नाही करायचं. ओके, phi of 0 is equal to 0 and phi of pi is equal to 0. Third one, phi of 0 is equal to 0 and phi dash of pi by 2 is equal to 0. Okay, solve करणार?
Yes, sir.
Yes, sir.
Okay. So in the next lecture, we see the existent theorem for the initial value problem. Okay. So for today, it is sufficient. या प्रॉब्लेमला इनिशियल व्हॅल्यू प्रॉब्लेम का म्हणायचं, कारण की तुम्हाला इथे इनिशियल कंडिशन तुम्हाला दिलेले असतात. फाय ऑफ एक्स नॉट, हा एक्स नॉट काय असतो तुमचा इंटरवलचा सुरुवातीचा पॉईंट एक्स नॉट. ओके, एनी डाऊट अप टू हिअर? कोणाला काही शंका असतील तर ते विचारू शकता. ओके, एनी डाऊट?
No, sir.
No, sir.
प्रॅक्टिस कराल थोडं पेपर इझी जाईल. यात कन्सेप्ट वाईज तुम्हाला म्हणजे असं मेकॅनिकल पार्ट आहे हा सगळा, ऑर्डिनरी डिफरन्शियल इक्वेशन आणि पार्शियल डिफरन्शियल इक्वेशन. ओके, सो वेट मिनिट, अटेंडन्स घ्या. Okay. So thank you for attending the lecture. You can leave now. Okay. Thank you. काही डाऊट आहेत का तुम्हाला?